Okay, in this video we're going to do an introduction to functions. And the first thing that we want to answer is, what is a function? Before we try to answer that question, I want to sort of give you a few examples of situations that we can use to understand what is a function and what is not a function. Consider a store. Let's say you might go to a grocery store or maybe a convenience store, and they sell a lot of different items at the convenience store. And when you, let's say, go to the grocery store, let's say that you're going to buy 7 items at the grocery store, maybe a box of cereal, maybe a gallon of milk, a loaf of bread. You might buy, let's say, a frozen snack, that you can heat up in the microwave or something like that. And every single item has a price associated with it. So, for example, let's say that you were to buy a box of cereal, and the box of cereal is $5. Let's say you buy a gallon of milk, and let's say that the gallon of milk is $4. Let's say you were going to buy a loaf of bread, and let's say the loaf of bread is, let's say the one you buy is $2. Let's say you buy a frozen pizza, okay? And then the frozen pizza, let's say that that's $7, okay? So let's say you have these 4 items, so not 7, let's just stick with 4. And then you bring these items up to the cash register, and they scan each one of these items. You know the little barcode? They scan the item, and what they're doing is they are inputting this item into the register that you're purchasing it. And then what comes out is how much money that you have to spend to buy it. So what we have is, we have the input, and then we have the output. So when they put cereal into the computer, out comes a charge of $5. When they put the milk into the register, into the computer, out comes a charge of $4. When they put the bread into the computer, out comes a charge of $2. And when they put the pizza into the register, out comes a charge of $7. And so what we can do is, we can actually, this creates a set, a sort of mathematical set that we can represent using set notation. So this is like a set bracket or a set brace. Okay, so I'm going to open with one of these braces, and what I'm going to do is, in parentheses, I'm going to write cereal and put a comma and put $5. And so what we're saying here is, the input is cereal, the output is a charge of $5. Okay, and the input cereal results in, or is associated with, a charge of $5. Then we would put a comma, and then we would do a new pair. This is a pair. The cereal goes with a charge of $5. Milk goes with a charge of $4. Okay, comma. Bread goes with a charge of $2. And then pizza is associated with a charge of $7. And then I'm going to close the brace off. This set is representing your visit to the grocery store, okay? And it includes 4 items: cereal, milk, bread, and pizza. And for each one of those, there's an associated charge: $5, $4, $2, and $7, okay? And so now I'm going to give you another example that we can use to understand functions. All right, so let's say you go to the store with a friend. Let's say maybe a gas station or a convenience store of some sort. And you guys are both going to get snacks. And you go in and you go pick out, you decide you're going to get a hot dog. And then you are also going to get SA stands for sour apple. I love sour apple frozen drinks. You decide to get a sour apple drink. Your friend gets a bag of Cheetos and also gets a sour apple frozen drink. Okay, so you guys both, and it's the same size, you both get a medium. So you guys both get the exact same drink, but you got a hot dog and your friend got some Cheetos. You go up to the register to pay, and you put your stuff up on the register, or, at the register, and they scan it. Here's the input, and the charge for the hot dog is $1. And the frozen drink, the sour apple drink, when they ring that up, the charge for that is $2. And then you pay. Then your friend goes up, and your friend puts the Cheetos up, and they ring that up, and the Cheetos are $1. And then your friend puts their sour apple frozen drink up, the exact same drink that you got, and they ring that up, and it comes up at $1. And now you're confused and upset at the same time. You're thinking, how come your sour apple drink is $1 and my sour apple drink was $2? That's very strange. It's really weird, right? Okay? And so what we have here is we have, you had an input of a hot dog and a sour apple drink, and they had an input of a Cheetos and a sour apple drink. And so what we really have here is only 3 inputs. Okay? These are not 4 inputs. Because the sour apple drink is the same product, it's the same input. Okay? But if we were to write this out as a set, we would get something like this. Okay? We'd get the hot dog, comma, $1, comma. Then we'd get the sour apple drink, and that for yours was $2. Then we'll have the Cheetos, which were $1. And then we have your friend's sour apple drink, which was $1. Okay? And so this is really strange, because even though you both got the same input, they rang up the exact same product for both of you. When they rang yours up, it gave a charge of $2. But when your friend's was rung up, it gave a charge of $1. And so this is a strange circumstance, okay? And what we would say is that this is not a function. See, with a function, if you put the same input in, no matter how many times you put the same input in, you should always get the same output. But in this case, we put an input of the sour apple drink, and we got an output of $2, and over here we put in the sour apple drink, and we got an output of $1. Therefore, this is not a function, okay? And so let's remember that. I'm going to give maybe one more example, and we should have a better understanding of what a function is. All right, here's our third example. Let's say that there's a neighborhood, and there's a lot of houses in that neighborhood, and in that neighborhood there are 5 houses that are for sale. Okay, so they're trying to sell them. And we took some information on these 5 houses for sale, and we counted how many bedrooms were in each house, and we identified the price that's being asked on each one of those houses. So we have house number 1 has 4 bedrooms, and they're asking $390,000 for it. The second one has 3 bedrooms, they're asking $350,000. The third one has 4 bedrooms for $410,000. Then one has 5 bedrooms for $440,000, and the last one has 3 bedrooms for $375,000. So what we have here is the input is the number of bedrooms, and the output is the price. And what we want to know is the price a function of the number of bedrooms? Well, we can do this by setting up a set of the 5 houses. The first house is 4 input, output $390,000. The second one is number of bedrooms 3, output $350,000. The third one is 4 bedrooms for $410,000. The fourth one is 5 bedrooms for $440,000, and the last one is 3 bedrooms for $375,000. This is our set of 5 houses for sale in a neighborhood, and we want to know, is the relation between the number of bedrooms and the price, is it a function? Okay? And so here's what we have to look at. We see 4 as an input right here, and we see 4 as an input right here. So 4 shows up as an input, the same input. But the question is, does it have the same output? And here, the output is $390,000, and here the output is $410,000. And because there's a different output for the same input, it is not a function. It is a relation, however. We can also see the same thing here, an input of 3. This input of 3 has an output of $350,000, and this input of 3 has an output of $375,000. Okay? And so this is not a function because with a function you cannot have a different output twice if you have the same input twice, okay? There has to be one output associated with each input, okay? And therefore this is not a function, okay? And so we're going to wrap this up. I'm now going to show all three examples, and we're going to try and get an understanding to see which ones are functions and which ones are not. Okay, so let's wrap this up. These are the three situations that we had. And what we're looking for here is we're looking to see if there is an input that shows up more than one time, but the second time it shows up, or the third time, when one of the additional times it shows up, it has a different output than it did the first time. Okay? And so here we have an input of cereal, an output of $5. Input of milk, output of $4. Input of bread, output of $2. Input of pizza, output of $7. No input has shown up again a second time. Each input shows up just one time, and therefore this is a function. Yes, so we'd say yes to this. But here in this next one, sour apple drink shows up 2 times. And the first time it has an output of $2, and the second time it has an output of $1. Therefore this is not a function. And then this one, the houses, we have 4 shows up 2 times, and 3 also shows up 2 times. The first 4 has an output of 390. The second 4 has an output of 410. And that's all we need, but I mean, just to push things further, the first time we see 3, it's 350. The second time we see 3, it's 375. And because the same input does not have the same output, that means we have 2 outputs. 2 different outputs for the same input. So that is not a function, okay? And so this is the idea of what is a function. And we'll explore this just a little bit more in the next video.